First Officer Bryan Lesko is the chair of ALPA's Aircraft Design and Operations Group, and he has assembled a panel of experts that will be discussing several of the most important safety-related issues the ADO group is facing. This includes electronic flight bags, or what we call EFBs, wake turbulence, unmanned aircraft systems, and ice crystal ingestion, a wide variety of topics to cover. Bryan, you all set?
Absolutely.
Over to you guys.
As we look forward to fortifying today's aircraft for tomorrow's threats, we got to take a look back for a second. Look at what's on your desk now, these smartphones. Over a decade ago, they weren't the same devices as they are now. Let's go back even further for just a minute. Look at a personal computer. 30 years ago, very few people owned a personal computer. In fact, they actually started about 4 decades ago. I'm not trying to date anybody in the audience, but my, how time flies. Today, it seems like nearly everyone is glowing at one of those handheld devices. In fact, in 2016, 2/3 of Americans owned at least one portable tablet device. Because each generation of technology improves over the last, the rates of progress from version to version increase and speed up. Imagine making a chair with hand tools, power tools, and assembly lines. They get faster after each step. Now, the tools also improve. Let's apply that to our craft and our profession. Think about when we learned to fly. Some of us well over 2 decades ago, 3 decades ago. That Cessna 150 you jumped in may have had a pull starter. That MX 340 manual tuning unit has more in common with a boat anchor than today's glass cockpit aircraft on technologically advanced aircraft. How far we've come with the development and operation of our airplanes. The ALPA Aircraft Design and Operations Group attempts to examine new technologies, vet them properly, work within the ASO to keep the flying public safe and keep threat and error management at our forefront. We have a seat at the table, as Mark said, for topics such as wake turbulence, operation specifications, master MEL development, aircraft braking friction, engine ingestion, including bird and ice. Additionally, we're involved with across the ALPA ranks regarding cabin air quality, new rules for flight control system development, electronic flight bag, and a little small topic you may have heard of called UAS. We've assembled a stellar group of panelists today. Ms. Melissa Bravin from the Engine Operability Department at Boeing. We have Dr. Ed Johnston from the FAA will discuss wake turbulence. Mr. Shane Gilman, who is the electronic flight bag and program manager for United Airlines. And First Officer Jim Pala, who is the UAS project lead for the Airline Pilots Association. Now, I will state one quick caveat before we get started, is that some of our panelists may not be able to answer your questions as it pertains to specific proprietary architecture, IT, or further research. So don't take it personally, but think about that as you formulate your questions. With that said, ladies and gentlemen, please join me in welcoming these folks to the stage. Now that that's out of the way, let's talk about ice where it's just not for drinks. Ms. Melissa Bravin is in charge of the Propulsion Department and ice crystal ingestion with Boeing. So what I want to talk about this morning is I understand you work on the Ice Crystal Working Group and the Ice Crystal Consortium. Can you talk about what that group is about and how it impacts the pilots and how it impacts the engine development?
So certainly, thank you for having me here. As you said, I'm a propulsion operability and performance engineer at Boeing. And actually the Engine Icing Working Group and the Ice Crystal Consortium are actually 2 separate groups, although there's a lot of crossover in membership between those 2 groups. The Engine Icing Working Group, or EIWG, is an industry group that brings together the regulators, industry, and research groups. And so our focus is to discuss industry issues related to ice crystal icing and also provide recommendations and guidance for compliance to ice crystal icing. So I'm currently the airframer co-chair for that group, and my engine manufacturer co-chair is Jeff Jones, who's an icing specialist engineer from Rolls-Royce. The regulators currently involved in the EIWG are the FAA, EASA, Transport Canada, and ANAC from Brazil. The Ice Crystal Consortium, on the other hand, is kind of a pay-to-play industry group. It's just industry members currently. It's Boeing, Airbus, GE, Pratt, Rolls, Safran Aircraft Engines, and Honeywell. And so we pull together small amounts of funding annually in order to conduct fundamental research into ice crystal icing, the effects of accretion, and the effects on engines. So recently, the Ice Crystal Consortium conducted research on a Honeywell ALF 502. That was on a BAE 146 aircraft in the 90s, and they experienced ice crystal icing encounters in flight. And we were able to take that engine and highly instrument it and place it in NASA's Propulsion Systems Laboratory facility. And with this test, we were able to replicate the engine accretion conditions that we saw in flight and replicate the particular failure mode unique to the ALF 502. This was really encouraging, and actually we are planning on doing a component level test of this same engine coming up at the National Research Council of Canada next year.
Great, thanks. So when we talk about ice crystals, what is the major issue? Why is this becoming a new issue to our pilots?
Well, so it's not really a new issue. I mean, we have seen events back spanning several decades, but really the upcoming technology has allowed better identification, better awareness, and better communication about ice crystal icing. So really, Boeing got involved in the 90s. You know, prior to that, we had seen several in-service encounters, but we didn't know what they were. We didn't think that they were ice crystal icing. We thought they were some other form of icing. There must be some other failure mode, but as we have improved instrumentation and awareness, that we have been able to corroborate that, yes, indeed, as we go back into the archives for infrared satellite imagery, we've been able to verify that these events were due to ice crystal icing.
So when we talk about ice crystal ingestion, they may include engine rollback, correct? Is that?
That's correct. Several different failure modes, including power loss and damage.
So many in this group have flown airplanes for decades without an engine rollback. Is it because the new technology that is making it more susceptible to increased research?
Well, I think there's sort of two parts to this question. So there's increased awareness on the part of industry as well as flight crews. You know, if we're able to recognize the condition, we can call it out. And for anyone that is flying Boeing products, you can always contact me. I have a stack of business cards later. But also, different engines have different susceptibilities to ice crystal icing. Some are robust, and we do see some encounters.
So can these ice crystals be detected on an airborne weather radar?
So the thing to note about ice crystal particles is that they're quite small. They're on the order of baking flour. And so because of their small size, they're actually quite poor reflectors of radar energy. So pilots sometimes report seeing green or speckled yellow radar at flight level, but oftentimes, you may not see anything while you're flying. However, one condition is always true in ice crystal icing. You will be in IMC. You will never be in clear air if you encounter ice crystals.
Are there any additional symptoms or any additional things that pilots can tell that they're in ice crystals?
So as part of our reporting encouragement from flight crews, which, you know, if you encounter ice crystals, we encourage you to contact us and just talk about it. You know, we're just interested in gathering more data and getting more understanding as to the effects that flight crews are seeing on flight decks. And so some symptoms that we have seen reported from flight crews include speckled green on the weather radar, as I mentioned. There might be a sound or appearance of rain on the windscreen. However, you're too high and you're too cold to have actual rain happening. You might see a small collection of ice particles on the wiper post. You might hear a shh sound. You may have a TAT anomaly. Your TAT probe may suddenly start reading near zero. You may sense that the cockpit is humid, or it might smell like ozone. You also might see St. Elmo's fire or even experience an engine vibration.
Excellent. So I have one more final question, and I wanted to talk about engine certification for just a quick second. What are some of the tests that engine manufacturers would have to go through to certificate an engine?
So engine manufacturers certify the engine to a wide range of conditions and failure modes. Those include inclement weather such as hail, ice, rain, and other water ingestion, as well as hard body ingestion and soft body ingestion like birds or slab testing.
Very well. Thanks very much. And
Thank you.
I'm going to leave this open to the floor as we get further on down that point, because I'm sure we all have a handful of questions for Ms. Bravin. I'd like to move down the line to Dr. Ed Johnston, who is the Chief Scientist and Technical Advisor for the Federal Aviation Administration. Dr. Johnston, can you elaborate what a CSTA does within the organization?
Yeah, sure. There are about 20 of the SISTAs for the FAA. They are all specialized in one particular area that's unique to their expertise. So we have SISTAs that do icing, software, human factors, upset recovery. I happen to be the one for wake turbulence.
Very well.
We're all resources for the FAA, for senior management for the FAA and anybody else in the FAA, as well as the external community as well. So we do outreach to external groups such as this and anything else that comes up. SISTAs also get involved in research, sometimes running programs, and frequently involved in testing of aircraft for wake turbulence purposes.
Thank you for being here. We do have your PowerPoint up if you'd like to use any portion of that.
Oh, thank you.
And
let me just quickly chime in. This is my first ALPA Safety Forum. Thank you for the invitation. I'm happy to be here.
Yes, sir.
Appreciate that. And the point that I wanted to make is that ALPA has been an integral player in all of the wake turbulence that the FAA has been doing for years, and we appreciate your support and help.
Yes, sir. Thank you. So changes to wake separation have occurred now at 31 airports in the U.S. Professional pilots may or may not have heard of the RECAT program. Can you elaborate on what types of wake turbulence changes have occurred throughout the NAS that may affect our pilot group?
Yeah, and ALPA flies on 6 continents, so many of your members are very well aware that the wake turbulence separation standards differ in various parts of the world. But it may not be as well known. As Bryan mentioned, RECAT has gotten a lot of press. In the U.S., we have implemented wake turbulence solutions at 16 TRACONs and 30 airports. And RECAT is just one of the solutions that we have in operation today in the NAS. So if you have flown into any of the major new airports in the New York area or in Northern California or Southern California, Pennsylvania, Miami, you have flown separation standards for wake turbulence that recently changed. The RECAT is a wholesale change of the separation standards, moving away from the heavy, large, small categories into more narrowly defined categories, and you can then have different separations between the categories. In addition to the RECAT, we have also done one of the first, if not the first, separation change in the NAS that was based on crosswinds, based on winds and weather. And that was done at 3 airports. It mostly was used at San Francisco. And when the crosswinds are sufficiently strong, we could remove the hold, the 2-minute hold or 3-minute hold for wake turbulence if you were departing from a parallel runway after a heavier 757. We also have separation standards that have changed for closely spaced parallel runways and diagonal separations. And in fact, there's a new rule coming out next week that now will allow heavies and 757s to participate in closely spaced parallel runway operations as leaders at reduced separation. And so those are across the NAS and growing. In September, we will be implementing the RECAT in the Potomac TRACON, and so that will pick up the Dulles, Reagan, BWI airports.
How do you judge the effectiveness, reporting-wise? What can pilots do for reporting wise if they happen to get a wake turbulence event?
Oh, sure. Well, that's one of the areas where we really count on ALPA and appreciate the support. We're not everywhere in the NAS. We do have some tools that we're working on that can detect wake turbulence post-flight using recorded data. But today, the mechanism for determining how often wake is occurring and significant wake turbulence is all about the reports that the pilots submit. So those of you that have submitted, thank you very much. For those of you that have had wake encounters and chose not to submit for one reason or another, we understand, but that does help us out if we get those reports. We have, as part of the post-implementation requirements in the SMS safety management system, that the FAA uses a requirement to do a post-implementation study and examine if we have created any risks in the NAS that exceeded what was there before, or if there are any problems, and that all depends on reports in order to know how that's going.
Dr. Johnson, thank you. What are the challenges you see from your perspective with the implementation of next-gen while continuing to increase capacity, but yet also maintain that safety side of the house?
Right, and the WAKE program is all about maintaining or enhancing safety. So nothing that we do is ever intended to reduce safety in any way, shape, or form. What we are doing now is we are doing incremental changes. So all of the recats that have gone into operations, there's a recat 1, a 1.5, a 2. We now have a 2.5. They're all incremental small changes. And there are constraints on what we can do with these small changes. So we have, for example, constraints that controllers would normally deal with about 6 different categories without any kind of automation support. They can remember that in their head, and they can effectively operate a system that uses that. We know from the work that we've done what the pairwise separations are between individual aircraft. We are moving in incremental fashion through a series of improvements. So the first round is a phase 1, that's a static change. Phase 2 then involves more information on pairwise separations, and phase 3 is more of a dynamic change. Until we get to phase 3, we're stuck with categories. And that is one of the areas that's a real challenge, because we know how we can reduce separations and do it safely. But if we categorize aircraft, and we have, for example, a category that says heavy in it, then we have to protect against any other aircraft that might be in a following position, versus a pairwise where we know that the separations could be safely reduced. So as we move forward, we're trying to do incremental changes at this time, but we know what the path forward is towards pairwise.
Would you like to talk about some of the recat items on your slides, perhaps?
Only if you need to.
Okay.
And I did submit some recat slides for those of you that might not be familiar. One of the things that is not often known is that virtually all the surfaces on an aircraft contribute to the wake that ends up downrange. So if you have slats out, or ailerons out, or flaps out, or gear out, all of that rolls up in the near field, as we call it, into the classic counter-rotating vortices. As the wake decays in age, the wakes decay in time and not distance. Certain aircraft have stronger wakes than others, and the indication here is that if you're looking at maintaining a level of potential encounter at the blue line level, and you have an airplane that provides a red line level here of wake strength at that location, you can actually safely reduce separations. Here's the 3 phases I talked about for next gen and our safety goal. And then this is one of the slides that we use quite a lot in the current arrangement. If you have a 747 and an A306 in trail, the separation is 4 miles. If you have it the other way around with the A306 in the lead, it's still 4 miles. When you do the analysis, you can actually close up. The 747 can be closer than 4 miles to the A306, not the other way around. That is a safe separation. And then the way that the recat works is in the upper series of bars here, we have the legacy system. So you have the supers that are the blue bar on the far left, and then the heavies. Notice the large number of large aircraft. That's a very wide category, from 41,000 pounds to 300,000 pounds now, and then a small category on the far right. So what you can do in the recat is you can break these categories up. So the heavies get broken up into two categories, the larges also get broken up into two categories, and then the separations between the upper heavies stays the same. The separations here, the upper heavies, you can actually reduce the separations. The lower heavies, you maintain the current separations. And what happens as a result of this is by dividing the categories, you can reduce the separation safely.
And that's a great segue to my next and final question here with the super category of aircraft. With the recent Airbus A380 Challenger incident, what's being done with respect to wake separation regarding the super category in the en route environment as well?
Well, this came up in the conversations earlier in a panel this morning. And the FAA is actively looking into separations in the en route environment for super aircraft as well as heavy. Our colleagues over at EASA have recently released a safety bulletin, and they have noted that in-trail distances anywhere from 5 to 25 miles in the en route environment might result in a wake encounter. It's a seldom appreciated fact that the 5-mile separation that is used in en route is not proof against a wake being there, because wakes last much further downrange than 5 miles. So we know the science involved in the decay of the wake, the decay in time, the distances we can work out from the atmosphere, and the atmosphere has a first order effect on how long the wakes last. We need to think then about what are the separations that we're going to use for heavies and supers in the en route environment, and that's an active discussion at this time.
Dr. Johnson, thank you. I'd like to move the transition into another topic that probably will strike a chord with many of you, and that's the electronic flight bag. We've been have Mr. Shane Gilman from United Airlines to discuss that. So Shane, you have the floor. Thank you for joining us.
Yeah, thank you. So first I want to second Dr. Johnson by having the privilege to address this group here, and I look forward to being able to provide as much transparency as to what we do and why we do it at United.
Very well.
And look forward to your questions.
Thanks very much. I want to start off with what are the major challenges that you've had implementing an EFB program?
Yeah. So our EFB program is pretty mature at United, as could be stated across the carriers. It's 6 years old, which correlates with the first development and deployment of a COTS device, which was the Apple iPad. So in a world of aviation where it takes decades for a technology to mature, we're pretty far ahead. But we struggle in a couple areas. One is Apple is a consumer device, and it behaves as a consumer device, and the manufacturer treats it as a consumer device, and it's not necessarily geared to enterprise deployments. They're getting better, but it's not quite there yet. So Apple will, at their own whim, decide to push out new iOS versions with very little heads up to users. And we have to react to those updates by testing our various applications against these new iOS versions. At United, we control updates by policy, iOS updates by policy, because we have to report which is the authorized version that we're on to the FAA. And so we'll ask folks to hold. We'll ask our crews to hold on a particular iOS version because maybe not all of our applications are working with the next version. So an example, we're on version 10.2. The version 10.3 may not work across all 7 of our operational applications. And so we test and we test and we test against different versions of iOS until all applications work with a high level of reliability. Application developers like this methodology of agile application development, which means they'll quickly write an app, they'll throw it out there, and if there's problems with it, they'll come back, they'll fix it, and they'll send you a new update. But one of the things we've learned over time is application updates out to our crews can pose problems. The application may not come down, and we have a crew that's getting ready to go, and you know, we run a 24/7 operation, so doing application updates causes a lot of angst amongst crews, and frankly myself. There's a lot of Malocs in my cabinet. So we try to hold major updates to applications to 2 per year for our critical applications. And so we have to work really strongly with our vendors to make sure that every application that they give us work extremely well with the anticipated versions of iOS that we want to take. So we notify them, hey, we're targeting a specific version of iOS that we expect to come. And so your application, you're going to have to get all of your development done within that one build, and it's got to work well. So that's always a continuing challenge for us. So we also lean on Apple pretty heavily as we acquire quite a few devices every few years, and they're learning to work better with the aviation community, and they're giving us some new tools, hopefully in the future, that will allow the onus of responsibility for what version of iOS is going to be that's going to be on the crew's devices to fall to us, and we can control that from our end, rather than having folks accidentally leak over my kid updated, etc. All of those good things that we struggle with. So it's probably our big struggle right now.
Well, Shane, thank you. What are the successes and failures that you've seen so far while implementing an EFB program at a large global airline?
Yeah, so I think our big success is we have convinced leadership within our company that the device is an extremely useful tool, and that it has a lot of potential going forward. And that has allowed us to equip our folks with the latest and greatest. We're on a dedicated 3-year refresh cycle. So we make sure that folks aren't going to have a device where the battery is dying too soon after they've gotten it, for example. So we've really had some success in demonstrating that it's a useful tool. The second piece, I would think, is we've, other than the obvious of not having to drag around a bunch of bags anymore full of stuff, we're able to test various technologies with the iPad to see if they provide an operational benefit or if it is a better quality of life for our crews. Can provide some better quality of life to the crews without having to do a significant investment in that test. So, legacy aviation gear takes decades, as I said, to get certified or to make changes to, and the iPad allows us to bring some new technology in rapidly, try it out. If we don't like it, we pull it back out and continue on and try something else. Failures, I think United we've made some. It is as I said, it's a burgeoning technology. It's fairly new. We consider it to be pretty mature, but when we first implemented it, there wasn't a whole lot of supporting vendors that saw the light of where we were going with a COTS device. And there wasn't a lot of options for us out there to utilize to make the device easy to use for our crews. If you're a United pilot in the room, we started off with a double suction cup ram mount, for example. And in our testing, that was one of only a few products out there that seemed to work. We deployed that. It worked well for a little bit, and then it had some very obvious flaws. It takes a little time to test and then redeploy a new technology, and we understood that if we were going to do it again, it needed to be done a whole lot better than we did the first time, and so we put a lot of thought into how this is going to work for the future. Apple has the ability to change their form factor at a whim with very little notification to us. So if you watch the Apple Developers Conference in the spring, that's when we basically find out what we're going to have to deal with in the future. So we had looked at putting permanent hardware in the airplane, a permanent cradle that was sized to fit our current device. And as you can probably imagine, a maintenance program is a fairly expensive thing. And had we gone ahead and put a cradle on board our airplanes that fit what we had currently, we would have had to start a whole new maintenance program and a lot of logistics problems that goes along with having to do an equipment swap because the new device that we will be rolling to in January of this next year wouldn't have fit that cradle. And so we had to put a lot of thought in how do we future-proof our technology, how do we future-proof the supporting hardware, and we actually ended up going with a system that allows anytime we get a new device, it will then clip into the interim hardware that we have on board the airplane, which is a suction cup on some aircraft and a tray on others. And we're then moving to a permanent mount that will accommodate that same factor as well. So I think we've managed to figure out how to take an initial failure, learn from it, and move on. And our goal is to make sure our crews know that we have a lot of angst in trying to make sure that they have a good product to work with.
Thank you. How is new software and hardware selected and tested for evaluation?
Yeah, so we have a pretty substantial process. We start off with an alpha user group of a potential application or technology that we're interested in or that needs to be tested, and there's about 20 folks. I have a number of special assignment pilots that work in my department, and we start off with them and they go fly with it. Then it moves to a beta tester group that's about 300 pilots, and we then send it out to line check airmen to do a much wider test before we do a line deployment. So it takes us quite a bit of time to get from point A to point B, but most of the time we have a fairly dependable software. So currently, based on the analytics we get back from our applications that report back in, we see about a 99.3% reliability rating of applications not crashing, et cetera, et cetera.
So with the advent of development of software, it's become how much do you put on an iPad versus how much do you put in a paper format? And I'm going to go ahead and ask this question. And at one operator, they've tended to go to an electronic QRH versus a paper QRH, and then back to the paper again. Can you elaborate what that process and how you feel about a digital QRH?
So I'm the flight operations digital guy at United. I have a personal opinion and I have a professional opinion. I think personally as a pilot, there's a place for paper. And professionally, I think United needs to spend some time thinking about how we want to use the iPad in the future. And if I was in a situation with an engine out, I'm not quite sure if I want to be flipping through a digital document. That being said, it is a new technology. We have a long way to go to figure out if it can be made better, if it can be made more reliable, more stable, and I would leave the door open for down the road discussions on how we should do it, actually. And I know leadership at United is waffling back and forth, and I think input from crews is extremely important to that. I know this was brought up a couple months ago within ALPA, and I've heard a lot of feedback since then, and I think that is probably the most important component of that decision is the front end user telling us what they think about that.
Very well, Shane. Thanks very much. Now I move down the line to First Officer Jim Pala, who has been the UAS Project Director for ALPA for 6 years now? 5, 6.
But who's counting?
220, 221, whatever it takes. Jim, we're going to talk a little bit about UAS here for just a quick second. What do you see as the biggest safety and security challenge for the safe integration of UAS into the NAS?
Okay, great, Brian. First of all, thanks for having us. Real quick, before I answer the question, I just wanted to say that this issue is on max thrust with no indication of letting up. 5 years ago, like you said, I've been covering it. There was 2 major events with maybe 8 meetings a year. Now it's 20 major events with 60 meetings a year. It's growing by leaps and bounds. We get great support from Captain Knoll down, the ASO level, you and Steve, And at the MEC level, from my MEC at FedEx has been very, very supportive. I have 2 other volunteers that help out, both United guys, Vance Patterson, he's at a UAS ARC that's going on right now, the ID and tracking, and Chris Lucius, another United guy who's in 787 training. And I'd be amiss if I didn't point out the great staff engineers, Mark Reed and other Ed Hahn and Edriel Bridger Newman, whoever helps us out in UAS. They have been very, very good. To answer your question, the safe integration of the UAS and the national airspace is the primary focus of our group. And the first major threat that we see is just the unbelievable growth of the hobbyist UAS, and that the internet is just littered with video of people who do not understand the risks that they're subjecting airliners to and where they'll fly them. So that is our first major risk. And how you mitigate that is, well, the first step was the FAA had a nice regulation that we helped write, the registration regulation, and unfortunately that was just overturned in court. So that will have to be corrected at in the next reauthorization bill. So that's probably the biggest threat. And also the FAA data that's out there from airliners sightings have grown 3 times since this year from last. And again, I'd like to put a pitch out there. There's a unmanned aircraft system near midair collision form on the ALPA website. So when you are flying out there and when you do see a UAS, please report it because we need the data.
Now, Jimmy, you were a Global Hawk pilot for a while, so you've got a lot of experience with this and flight beyond visual line of sight operations. As that's the end goal, what do you see needs to happen to operate UAS beyond visual line of sight?
That's a good question. And of course, an operating detect and avoid system has to be developed, and that will replace the human eyeballs on board the aircraft to see and avoid. And the technology needs to be vetted and tested, and there has to be a collision avoidance as a backup in case the system fails.
Jim, we talk about a lot of places where the industry may want to use the term operator versus pilot. What is the role of the human pilot in the UAS aspect, in the UAS regime, as it regards to safety?
Again, the autonomous operations and what we define as autonomous operations, as once the UAS is launched, its trajectory cannot be influenced by a human pilot on the ground. Those operations are currently not in scope. All the UASs that we are talking about are going to be remotely piloted aircraft systems where there will be a pilot who will be called a pilot, and we've kind of won that battle at the FAA, and that he or she will have the same authority as a manned aircraft pilot and receive equivalent training and any other additional training on anything unique to UAS operations like the command and control link, the detect and avoid system, and that's it.
Jim, what are your biggest concerns as a pilot that you see with the integration of UAS into the controlled airspace?
Well, like I said, the first is the collision risk, but then as they get larger and more mature and they begin to file and fly and operate alongside airliners in controlled airspace, that they have the same level of safety, that they're introduced gradually, a crawl, walk, run kind of introduction with very good safety risk management discussions and testing before they're allowed to fly.
Are there UAS out there now with collision avoidance technology, and is it even required? Well,
the regulatory world is still in the developing stage when it comes to UAS regulations. The small regulation, the FAR 107, which has been in effect for about a year now, is still only visual line of sight, daytime, and really only supposed to be in G airspace. The next step will be to go beyond visual line of sight with much larger aircraft. This regulations are still in the works. There will be an ARC standing up probably in the fall that will address some of this. And that our work at RTCA Special Committee 228 is developing the MOPS for this equipment. The Phase 1 MOPS has been come out, and there is a category of class of equipment that does not require a collision avoidance system. So there is been no operational approvals of using of this equipment, but it is something we're monitoring and watching.
How big are the UASs that we're talking about that would need this system?
Well, anything above 55 pounds, and it's going to go beyond visual line of sight. It's really.
So anything less than 55 pounds?
Well, that's still to be developed. If you're less than 55 but still want to go beyond visual line of sight, then our stance is that you have to meet the rules.
Very well. Jim, thank you very much. And while I close this, I want to take the opportunity to thank the AV staff in the back of the room. I want to thank the ALPA staff. I want to thank our panelists. I want to thank you folks for being out in the audience. I know Captain Harrison's working on his way up here, but I hope this has been somewhat beneficial. I hope this has been a learning experience, and this is going to be my shameless plug for about 30 seconds on my ADO group. I've got about 12 volunteers, and I could use about 7 more. So we are extremely busy across about 13 or 14 projects. My UAS team does 60 to 80 meetings a year. So a lot of those budget dues are being done to make sure that we don't impact one of our airplanes with a UAS among the other list of things that we're trying to do to fortify today's aircraft for tomorrow's threats. So.
And Brian, we are the only pilot group in the room. We are the voice of the operator and user of the airspace.
That's a very good point. We're it. So, guys, thanks very much. I appreciate it. Let's give them a hand for being on the panel, please. Thanks very much.